Hello everyone, I'm Tetsuya Kuma from Osaka University. The title of my talk is Improving the Accuracy of Spectrum-Based Fault Localization for Automated Program Repair. Let me talk about the background of our research. Spectrum-based fault localization is a technique to infer locations of defects in a buggy program. SPFL calculates suspiciousness for all program statements based on the spectrum and the pass-fail status of each test case. Developers can localize buggy statements earlier by examining more suspicious statements. This is an example of buggy program. This program takes two float values as inputs and returns the max value in them. Fifth line is buggy. T1 and T2 are test cases for this program. Executed statements are marked, and the sets of marked statements are spectra of test cases. From this program and test cases, suspiciousness is calculated like this. Suspiciousness for statements executed by failed test cases become higher than suspiciousness for statements executed by passed test cases. The accuracy of SPFL depends on the given test cases because SPFL uses only the information from the test cases. If the number of test cases is too small, the accuracy of SPFL gets low. For example, if only two test cases T1 and T2 are available and SPFL is applied, 4 statements are regarded as highly suspicious. By adding some other test cases, the accuracy of SPFL can be improved. If the test case like T3 is added, only the buggy statement is regarded as highly suspicious. However, adding other test cases like T4 does not improve the accuracy. The reason is T4 has the same spectrum as T1. Such test cases only increase the execution time of SPFL. SPFL is also applied to automated program repair, in short APR. In APR process, test cases are executed many times to validate generated patches. Consequently, adding test cases which do not improve the accuracy have a bad influence on APR from the viewpoint of the execution time. To improve the accuracy of SPFL while suppressing the increase of the execution time, we propose a technique to obtain test cases whose spectra are different from any original test cases. Adding such test cases enables to calculate more accurate suspiciousness for each statement. The proposed technique consists of 3 steps. Step 1, generating test cases. Step 2, collecting spectra of all test cases. And step 3, selecting test cases based on the spectra. In step 1, EvoSuite is used for generating test cases. EvoSuite is an automated test generation tool. A target program before defects occur is given for EvoSuite to generate correct test oracles. In step 2, original test cases and all generated test cases are executed to correct their spectra. In step 3, some test cases are selected from the test cases generated in step 1 based on the spectra. The criteria for test case selection is whether they have new spectra. Having new spectra means spectra are different from any other test cases. In this example, T3 and T5 are selected. because their spectra are different from T1 and T2. T6 also has a different spectrum from T1 and T2, but it is the same as T5. In such case, only one test case is selected. To evaluate our technique, we conducted an experiment. Research questions for this experiment are: 1. How much does our technique improve the accuracy? 2. How much does our technique suppress the increase of the execution time? Subject programs are projects in this table. These projects are included in Defect4J. Defect4J is a widely used bug dataset as a benchmark for FL. This slide shows results for the accuracy. The vertical axis presents the rank of the faulty statements in the ranking according to the suspiciousness. In other words, how many statements developers need to check until they identify the buggy statements. The white box plot is the case only the original test cases are used. The green box plot is the case the original test cases and test cases selected by our technique are used. The red box plot is the case the original test cases and all generated test cases are used. In case of math, comparing original and select is more accurate. Comparing select and all is a little more accurate. In all cases, our technique improves accuracy. Comparing to all generated test cases, our technique is almost the same or a little worse accuracy. This slide shows results for the execution time. The vertical axis presents the time required to execute test cases and calculate suspiciousness. Comparing select and all, select more suppresses the increase of the execution time. Let me conclude my presentation. We proposed a technique to select test cases based on their spectra to improve SPFL. Our technique improves the accuracy of SPFL and suppresses the increase of the execution time. As a future work, we are going to investigate effects of our technique for APR. Can repairability or the time to repair be improved? As another future work, we are going to extend EvoSuite to generate new spectral test cases directly, not select from generated test cases. Thank you.